Hey, what's going on YouTube, and welcome to this video on how to configure Cube for use with the Internet Telephony Service Provider, or ITSP, using SIP. Now, for those of you that have been watching the CUCM 11.5 playlist or saw the how to configure basic TDM gateways, PRI and FXO video, this is essentially going to pick up from there. But this time we're going to now configure Cube to work with SIP with a service provider. Now this setup is a little bit different than I was going to do originally, because one of the viewers had told me about the SIP-UA.com providing free lab service. So I checked it out, and sure enough, you can register for free and actually make real PSTN phone calls. And what I was going to do, and I still will do, but initially for this video I was going to have the simulated PSTN that we've been using for that, but in this case, since we can use this free lab, we're actually going to set up a Cube interface and route real PSTN calls inbound and outbound. The only difference is, instead of configuring it on the CME router directly, it's going to be configured on the PSTN router, which isn't available in the lab because I don't know what their usage policy is, if they want, if other people are using my login for their own labs type thing. But like I say, it's free, so just go to, if you're building your own lab and want to follow along, just go to the SIPUA.com, and as you can see under support, they have the getting started guides and how to essentially configure it. We're going to be doing it a little bit differently, but this should at least get you started. And then for the inbound calls, as you can see, you can dial this number here and then put in the extension that they give you, and you can make inbound calls. So that is what we will be doing here. Now, before we begin, I just made this little picture just to kind of get our bearings as far as what we would be using this for. As you know, so on your private network, you have your CUCM, which is essentially the database for all the endpoints, the users, SIP trunk, your voicemail systems. And if you have a multi-site, like Site B here, for example, you could have, and I apologize in advance because I don't have those fancy pens, I just have my mouse, so pardon my lack of drawing skills, but let's just say you could have like a MPLS VPN here to connect the two sites. So when a call gets set up and it's using this private IP space calling over, well, that's kind of a bad example. So like the phone, when it sends a call, asks call manager can send it to the extension to this other phone, and then the two phones can negotiate RTP and communicate directly and not have to pin through. Now, for what we're going to do, we're actually just a single site, but what's going to happen is, if we were to try to send calls out and use regular NAT through our ISP, and then go to an ISP that way, you're open for security risk. It's not really designed for that. But for our lab purposes, what we're going to be doing, and what we have been doing, is essentially we have a single site, and we initially set up our phones to, oops, I don't have my draw on again. We initially had our phones set up to get the dial plan information from CUCM, go to SIP trunk to Cube, and then it would use the FXO or PRI to our PSTN number, our virtual PSTN number. What we're going to do in this case is we want to, and we don't have a DMZ here, but what we're going to want to do is, when we set up our Cube, by default it's going to be flow through. So we're essentially making this border here where it's going to go from CUCM to the Cube, but then the Cube's going to rewrite the headers to send to the ITSP for its signaling, and then rewrite the headers going back directly to the phone. Same with RTP, so the RTP media on this side is going to have the private information, and the SDP is going to be rewritten on the outside going to the ITSP, and it's essentially going to be flowing through the Cube device. Now, times you would want to configure flow around, for example, is if you were using Cube for some reason and redirecting to something else within the same LAN, so then the media can flow directly between them on the local switch and not be pinned through. But a lot of times you might do that for call recording too. If you have, you know, forked SIP and SDP going to like media sense or something, you know, that's another reason we could do it. But again, just kind of a quick high-level review on what we'll be doing. And so here I have the remote desktop. I'm logged into YouTube user B because I saw somebody else is signed in now. Let me see. Looks like somebody from Australia is signed into the free lab beta right now. So hopefully I don't mess up whatever you're doing. I said I would take the VoIP Tech page down and block access. But I wanted to post or make this video last week, so I'm just kind of running with it. Hopefully we don't run into each other, whatever that person's working on. All right, so what I'll do is I'll log in, and I already created the SIP trunk. Again, if you're following the other video, the process is exactly the same. So if we go to our trunk here, or I'm sorry, if we go to our call routing route pattern, so here I called it real PSTN call, and it's literally almost, well, I was going to say literally the same, but pretty close. The only difference here is instead of changing the digits or anything, I'm sending the 9, and there's no digit manipulation, but sending it to the CME router. Whereas, for example, see, there's no discard digits or everything, whereas like the 10-digit dialing ones right now, it's removing the pre-dot and using a transform mask of sending 303.555, 8200 for so we'll send this extension to go out the FXO port, for example. So with this in place, so for many of our lab phones here, if we dial a 9 and then 10 digits, and again the brackets are just saying 1 digit, that could be 2 through 9. So we got 9, and for example 532 2 5 6 1 2 3 4. You know, something like that. That's essentially what that's doing, and we're routing it to our CME gateway. Now again, I had stated that, and let me pull up the picture here. This is, I will be updating on the VoIP Tech info page. I'll be updating that with this picture here after I finish this video. But essentially what we're going to be doing here is we'll log into here, because we got to think of call legs now. We created dial peers on the previous video for the PRI and analog interfaces. I didn't go into a whole lot of detail, but we'll cover some more here. And there's, you know, I could have a whole like 2-hour session just covering some of the basics of dial peers. So I'll cover some additional information as we go through here. But what we want to keep in mind is the call legs and order of operations. So what we're going to have, we have this real number that we're going to call, and then this is the extension we'll be dialing. So when the call first comes in here, the inbound, that's going to be, oh man, I'm really terrible at drawing with the mouse. Those squiggly lines are supposed to say leg. So leg number 1. Once it comes in, then we want it to come down this PRI interface as an outbound. I made that too long. So we got an inbound dial peer from the ITSP, then an outbound dial peer to go down the PRI, and then another inbound. So see, this is number 2, and we have number 3 here coming in to here, and then we need another outbound, so number 4, to send it to our call manager cluster. Man, that is terrible. But that's supposed to say call leg number 1, 2, 3, and 4. Then likewise, we need to have set up a outbound dial peer, because we already have an inbound dial peer coming from CUCM number 1. And then we want an outbound dial peer for here, going up to the virtual PSTN. And then another inbound coming in on this PRI, and then outbound again 2 for the other leg. So 1, 2, 3, and 4 to the ITSP. So that's what we need to configure to get the call flows to work right. My furnace just kicked on, so hopefully there's not too much background noise. So the point with this though is what we're about to configure on here, we would do essentially the same thing right here, except just for these call legs, we would be configuring them right here instead of having this extra hop. But that's just so that the SIP account with my password is on this router, whereas this one's the public accessible. So in future videos I will have other options, because another thing I want to do is show other examples on if you have, say, multiple trunks doing like single pilot registration with other DIDs associated with that. This one is just going to be a basic, because this is a real one, setup. But just keep in mind, if you're following along, you'd probably be doing it on this router here. So let's get into it. Alright, so I'm in on the console, but for you guys, if anyone that's following along, you can also go in through the 192.168.202.2 via Telnet. And based on the previous video, we had we set up a couple of dial peers. So if we show dial peer voice summary, we have the 2 pots that we had created, so one off the FXO, one off the PRI. And if we look at essentially our cube configuration, which oftentimes it's called the Cisco Unified Border Element, because you'll see it both verbally and documented as Cisco Cube, so it's kind of redundant, but I guarantee you've probably heard that. I've caught myself saying that too. So in this case, we have our voice service VoIP saying to allow SIP to SIP connections, and we have our publisher and subscriber on the list, and no SIP dial peers. Pretty straightforward, pretty vanilla there. So looking back at our diagram here, so we get the SIP call that comes into here. That's our leg 1. Now we want, and it's going to come in with the 9 and 10 digits, and we want it to go out the PRI interface. So what we can do is create a dial peer for that. So so far we got the tags 10 and 20, so let's go to config T, say dial peer voice 30, and this is going to be pots, because we're going to be using that interface. And in this case we'll give it a description of PRI to SIP T, and destination pattern, we're going to say, we can say 9 2 to 9 ... let's see, 2 to, oops, and 1 2 3 4. All right, so we got our 10 digits. and this is going to go out port 00023, and we'll forward 10 digits, so essentially stripping the 9. Now if it were a SIP interface at this point here, we would use the translation profile, which we will use here in a moment, but for now this should work. So back to our diagram, at this point we have where the SIP call comes in. It's now going to point out here. So now let's configure our PSTN gateway, and this shouldn't have anything other than some basic firewall settings. So let's see, show dial peer voice summary, nothing there. Show run section voice service, nothing there. So this one we're going to configure from scratch. So as you can see here, all it has is a IP address and a basic firewall. And as a matter of fact, the one here that's listed as firewall, they have an example somewhere on the SIP UA webpage. Let's see. Oh, right here, access list. So there you go. That's an example of very simple firewall you can do. All right, so now what we're going to do is configure Cube. And now this is a first gen. As you can see, this is a 2811. The main difference between this and a newer one is there's some extra commands on the Gen 2s, like the 2900 series. And just to show you, this is a device that I'm going to set up for some of the SRSTs for demonstrations. This isn't permanently in the free lab, but this is a 2911. And if you look at show run section voice service, one of the things you'll see here is right here, mode border dash element. If you're using a second gen, you'll want to add that in there. These older models don't have that, but that's pretty much the main difference for this config that we're going to be doing that you would add on the next gen. So here, let's go to voice service VoIP, and we're going to say allow connection SIP to SIP. Then address hiding. This is what's going to essentially, when you're doing the flow through, to keep the endpoints from seeing each other's actual IP. So devices on, oops, let's see, here's my picture. This command is essentially going to make it so when the SDP information goes through, it's going to see the private side, the LAN interface, for its media communications, and likewise any device on the outside, whether it's your ITSP or whatever you're doing, it's going to see the WAN side. So that's kind of like your NAT translation, so to speak. And this is something that Call Manager can't do. So if you were trying to register directly with another device out there, then you would, potentially run into those type of issues. So that's what that address hiding command does on Cube. I guess I should say too, Cube is really just a service on the iOS router. It's not anything special. And then we're going to do our IP address trusted list. And here we'll specify IPv4, and I'm just going to copy, these are the servers of SIP UA. Oops. All right, now for this video, essentially Cube is configured. Oops, I accidentally exited out. All right, so we've got our voice service VoIP allowing SIP to SIP. These are some defaults. Got address hiding, and the list. So now we need to set up our registrars, what we're going to use to register with. So we'll go to SIP UA, and for the outbound calls, you want to use Authentication, and you'll say username, and in this case, my username is the extension, which is 529901. Then you will say password, and whatever your password is. This one I'm going to put in fake for now, and enter. So now when we set up our dial peers, SIP dial peers is going to use this for the authentication, and then for credentials, you'll use that for registration. So when you send out the registration and it sends either a 407, for example, then this will send the MD5 hash of the user credentials with in the registration header. So same thing, we'll just say username and then 529901, password and my password, and then we'll add the realm of sip-ua.com. Didn't mean to put a space there. And needed to add a L there. All right. So if we do a show run SIP UA, we got our default credentials there. We could say, see, retry, invite, and we'll say 2. See, timer's trying in milliseconds. We can give it a second and a half, essentially. The way that they have their redundancy set up is when you set up your SIP server, for example, for your outbound, you could say IPv4 and an IP address. In this case, they're using DNS, so make sure you have a DNS configured, a name server configured on your router. And this time we're just going to say DNS and then proxy.sipua.com. Expires in 60 seconds. Or the expires is for registration. This is just for the outbound. So we're just going to say SIP server DNS. And then for registrar to register, it's going to use the same address, proxy.sip-ua.com. And now we can put expires, and in the value in seconds, we'll just say 60 seconds. Okay, so that looks good for our configuration. But now we need to create our dial peers here. Now, order of operations is important to keep in mind. Now, so far we've looked at the destination pattern, for example. And so in those cases, when it matches that, it'll obviously go out that peer. But the way that dial peers in general are set up is that first, when a call comes in, it's going to look at the incoming called number. And that's usually used for the inbound dial peers. And you can actually use them for both inbound and outbound, but generally speaking, that is going to take precedence, and it's used on the inbound only dial peers. Then you have your answer address, and that dial number, for example, is the DNIS, or the digital number identification service. And then the next one would be the answer address, which uses the ANI, or automatic number identification, which is essentially the caller ID, the calling number. And then you have the destination pattern that we talked about, and then the voice port. And there's an implicit dial peer 0 if none of those are matched, but only the first 4 that I mentioned are configurable. Now, if you are especially doing CCNA or anything like that, you'll have to memorize that and keep that in order. So there's a lot of different ways to do that. For me personally, it's all about repetition. I'll do things like Incoming answer address destination port. Dial peer 0. Incoming answer address destination port. Dial peer 0. Incoming answer address destination port. Dial peer 0. But that's just me personally. I know it's not everyone's cup of tea, but you know, if you play that through a couple of times, you'll remember, at least when it comes to testing. So what we'll do here is we'll first configure our inbound dial peer. Okay, and again, for those of you using a home lab, you would be doing it on this device here. This piece is moved over to here is all. So we'll go into, we'll create a dial peer. And this time we're going to use VoIP instead of POTS. And we can give a description of, we'll just say our PSTN inbound. And what was the first one? Incoming. That's right. So we've got our incoming called number, and it's going to be the 417-520-9020. That's what they send. And we'll say session protocol SIP v2. The session target is going to be the SIP server. Oops, SIP server. There we go. And we can, for DTMF relay, we can use our RTP NTE. Codec will be G711. Oh, and that's another thing. In Call Manager, if you weren't using Cube, you can only set the maximum bandwidth. So you can set the highest codec and then have the endpoints negotiate, but you can't technically force a particular codec unless you use the smallest one there is. So if there's specific codecs that you need, that's another reason you would be using Cube. And we'll put in NOVAD for no voice activity detection, and that's that feature where to save bandwidth, if you stop talking, it stops transmitting, but then when you start talking again, there's like a little delay before it starts transmitting again, so the first part of your words get cut off, and it's pretty annoying. So most people don't use that anymore. Now, one thing that we're going to want to do is in our environment here, another user connected to the remote computer. Sorry, person from Australia. They're still connected, so they're actually doing something on there. Maybe they're not using, let's see if they're using hopefully we didn't kick that person out. Okay. I will pause the video for this part, but again, as a quick recap, if any of you using the free lab get that, you have to go to the resources here and say play on remote computer. Then you can load it. And then once it's loaded, you disconnect, change it back to the local machine, and sign back in. So let me do that real quick. Alright, so I think I'm going to have to reboot the whole ESXi server. The memory is 100% maxed out, and it's not even pulling stats right. Of course, it's always Murphy, and then all the devices aren't pinging right now either. So I don't know if you guys can see this, but it's basically completely maxed out. So I'm probably gonna have to reboot this thing. I tried powering off a virtual machine. The person from Australia signed off because whatever they're doing probably realized it's not working now. So well, never had that happen before. Alright guys, so let me reboot this whole thing and hopefully we can continue. Alright guys, well, as you can see, I updated the webpage. The server is down and I can't fix it yet. So it's already getting pretty late, so I am going to work on this, and if I can't get it running within the next hour, I'll probably continue this video tomorrow. But I'm gonna stop the video and see what happens. Alright, I'm back. So it's been about an hour and 15 minutes or so, and basically found one of the hard drives failed. Spent the last hour trying to get it rebuilt, and I think as long as Murphy doesn't bite me again, hopefully we can finish this video. I was planning on doing the SRST with this format tomorrow, but we'll see how the hard drives hold out. I see that one of my lab phones is registered. Everything's still booting up right now. So you can see the CPU's kind of huffing and puffing. But hopefully this will stay up long enough to finish this. Now with that said, I kind of lost my train of thought where we were. I know I was trying to get into a remote desktop for something, and see, we just built the, let's see, where's my sessions here? Okay, so in our PSTN, I think we just built the first so essentially back on, and there's nobody logged on the VPN now, and so I'll keep that message up until after this video. Oh, and I was using the other picture. So at this point we stated that, okay, with this dial here for inbound, the destination address that's going to come in is this 417 number. But now to get it to our devices, we have 4-digit extensions. So one of the questions could be is, do we want when you call in, do you want it to ring the actual extension of the phone? Do we want it to use the contact center? So let me try the remote desktop again. Might as well try 102. That's one we were going to use. And then somebody signed in. Well, this is a good sign. But IP communicator isn't launched yet, so I think I already said this, but I was saying to play on the remote computer so you can launch it. I think that's where it blew up, because then I went to sign back in and then I couldn't get in anymore. Alright, so now that this is registered, I'm just going to disconnect and then sign back in. But first changing the local resources back to play on this computer. And now, should have. And I don't know, like I say, how well this is going to work. Hopefully we can use this. Alright, well, alright, so we at least got dial tone, so, and as you can see, the things are still kind of huffing and puffing, so I'm not too worried about that. As long as it stays stable, we can finish our configuration and then make some test calls. This is what your servers look like when you oversubscribe them and don't have hardware resources, so this might take a while. All right, so for the time being, let's just assume that if everything works, the extension 5000, for example, was one of our, on the UCCX, Contact Center Express, that was one of our scripts we set up in a previous video. So let's set up a dial peer to allow that, or to transform that incoming called number to a 5000 extension. So what we're going to want to do is, let's see if we look at, should have the 1, and it's just saying, okay, it's going to be this incoming called number. So what we can do is we'll say config t, we'll say voice translation rule, give it rule number 1, and for rule 1 we'll put in this number and then space and then 5000. This is a very basic rule saying if you match this exact number, replace it with this. And then we'll create a profile to apply this. So we'll say voice translation profile, and we'll call it SIP UA. And then now we can go back to our dial peer. See dial peer voice 1, and we'll say incoming or translation profile, and then you can see if it's for incoming or outgoing. In this case, we want to apply it as it's coming in, so we're going to say incoming and then SIP UA. So that should change that destination pattern. Now we need a destination pattern for those 4 digits. So in this case, we'll say dial peer voice, and we'll give it tag number 2, and this one's going to be POTS, because again, we're now creating the outbound dial peer to send across the PRI. So we can give it a description SIP T to PRI, and we'll say destination pattern, and we can just say 1, 2, 3, 4. So any 4-digit pattern. We'll say 4 digits all. And now if we were to look at do show SIP UA register status, actually get out of here. Let's see. Show SIP. Or, oh right, I haven't given it the port yet. What I was going to show you is this is going to be port 00023. Now let's see if, so see, it tries to register by default whatever you have for the destination pattern on the POTS peer. So what you want to do is say no SIP register, so that way you can actually see. Now the reason this isn't registered is because I didn't use my real username and password, so let me add the real one here. So now we can see that it is registered, so we should be able to make inbound calls. And at this point, so we've got the inbound call that's going to show a destination number of this 417 number. It gets translated to 5000 and sent across the PRI. So now if we go back to our CME, if we do show dial peer voice, summary, you can see we've got our outbound dial peers, but we don't have anything because we need to get, now that 5000 has got to CME, CME needs to get over here to the call manager. So we need to create another dial peer. So we got 10 tags 10, 20, and 30. So let's just do let's see, dial peer voice 40, and we'll call it VoIP, and we'll say to CUCM, and destination pattern 1, 2, 3, 4. We'll give it the same 4 dots. Destination pattern 1, 2, 3, 4, and session protocol SIP version 2, session target IPv4, and our publisher 192.168.202.211. And just like we set the other ones, we can set the DTMF relay RTP and TE. Give it the same codec of G711 EULA and NOVAD. Okay, so now in this case, in theory, a call should be able to come in. So what we can do is go to our PSTN, and let's do a debug CC SIP messages, and let's see if we can use this method here to make our test call. So let's see.
Please dial your lab extension after the tone.
529901.
Congratulations, you have just completed the call over the PRI interface on serial 0/0/0. Now, is your call on channel 23? Is it on channel 1? Are there any configuration changes you can make to make the call hit another channel? Give it a shot and make another test call.
Thank you for calling. Your call is important to us and will be answered as quickly as possible.
All right. Well, that worked, but that definitely did not do what I anticipated it to do. Alright, so let's see here. My guess is something didn't go right with the translation. Let's see if we do a debug ISDN Q931. Let's do that call, make that call again. Let's see what it looks like going across the PRI from the PSTN side. Should be just the 5000.
Congratulations, you have just completed the call.
That's why. Called party didn't change. So let's see if we do test voice translation rule, and let's do that was what, 417 520-9020. 500. Still should be 5000. Okay, so let's just do this. Did I not, well, it is almost 3 in the morning, so maybe I forgot to, let me see, voice translation profile, SIP UA, and we want to say translate the called number to translation rule 1. Sorry guys, I must have missed that. So now it should work. So let's redial.
Please dial your lab extension after the tone.
Thank you for calling.
That's what we want to
All our
see.
representatives are assisting other callers at this time. Your call is very important to us. Please stay on the line, and your call will be handled in the order it was received.
So let's undebug all. So basically, I had forgot to, I created the profile, but then I didn't put any rules in it. So I needed to tell it what to do, and that was to translate the called number to voice translation rule number 1. Alright, so now that we have that going, and we're in here, now what I could do is, that was our UCCE, so we can sign in. I didn't, server's still looking pretty heavy, but we're able, UCCX is up obviously, so I'll change this to a status of ready, and let's see. All right, so I will give this a call again.
Please dial your lab extension after the tone.
Thank you for calling.
Alright, so now we can see the call coming in, and we can answer it. And now we have a call. See, can you hear me on this? Can you hear me? Testing, testing. Yep. So yeah, so you can see you got a real call coming in. And just hung it up, so it's in wrap up. Then it should go back into ready after 10 seconds. I think that's what we set it for in one of the previous videos. So now it would be nice if we could make outbound calls. So all we have to do at this point is finish setting up the dial peers to go the other direction. So from our PSTN side here, we have our inbound that then translates the dialed number to the 5000 and sends it over the PRI, and then it goes SIP to the cluster. So now for the other direction, since I'm in the US, I'll make 10 and 11 digit dialing, but if you're doing your own lab, you know, you can set obviously the patterns for whatever your country code is, or country format is. But so we'll create another dial peer here. So dial peer voice 3, and this is going to be VoIP, and we'll say description, we'll say 10 digit dialing, and we'll use destination pattern. We'll use the 2 through 9. ... 2 through 9. ... 1 2 3 4. And this is going to be session protocol SIP version 2, and session target is SIP server, and the DTMF E and codec G711 EULA no VAD. And I could actually do a so just make it a little faster. Oh yeah, we can do this. Say like dial peer voice 4 VoIP. Paste this in and then just change the description to 11-digit dialing. And for the destination pattern, I'm just going to add a 1. So now if we do our show dial peer voice summary, now if anything comes with 10 or 11 digits, it's going to set it out to our SIP server. Which we configured earlier. Alright, so we've got the outbound from here going on. Now we just need it, and we, in the beginning of the video, I showed you that we had the 9+ digits going here, and then we set it up to send 10 digits. So let's see if we can make an outbound call now. Another user connected. Did they really? Let's see. Hey, the same person from I can just tell by their IP. I don't know who they are. I can't actually see what they're doing, but it's the same IP from earlier for the person from Australia. So they're back on. So we're kind of, so in this case we're fighting each other because he or she, whoever is using it, is on that remote desktop session. So let me try the third one again. Let me see if they're in there or not. Alright, so let's make sure I get dial tone. Alright, so I'm getting dial tone. So now let me call, I'll dial 9 and see, oops, I didn't dial. You have 3 seconds. We set that up in one of the other videos. So let's see, 9630. Alright, so now my phone's ringing. We got a break in the connection, it sounds like. Stuck on answering. Let me try
You will now hear your own voice in an echo test.
all right. So before this blows up again, I think that's the first piece that I wanted to show you anyway, where with the SIP UA that again one of the viewers told me about and I tried, you can set up the dial peers and actually get real PSTN calls. They limit you to 2 minutes, but I mean it's perfect for lab use, and it's free, and that's exactly what I was looking for. And I'm still going to do the virtual PSTN at some point, but probably next video I'll add based on the requests are the SRSTs, and I'm going to try, as long as this hard drive doesn't crash again, I'll try to get that video in tomorrow. And yeah, so if you have any questions, let me know. If you want to go over, you know, dial peers or any, I'll be going more in detail with that when I do a refresh of the Call Manager Express series. But in the meantime, if you have any questions, let me know. And as always, thanks for watching, and I will see you guys in the next video.